Okay guys, so for this screencast, it just shows how to create a position time graph based off of scenario. Okay, so a student rides a bike every day to school. During today's commute, he traveled at a constant rate of 100 meters per minute for 15 minutes and arrived at school. When he arrived, he realized that he forgot to do his physics homework on the couch. He forgot his physics homework on the couch and pedaled back as quickly as he could. He arrived home in 5 minutes, only to realize that he forgot to do the last problem. He quickly pulls out his calculator and does the last problem on his homework, and it takes him a total of 3 minutes. 3 minutes to finish his homework. He then pedals back to school at a constant rate of 250 meters per minute. How far was his school from his house, and how long did the student take in the entirety of his trip? Okay, so before we can do anything, we kind of have to do this position time graph, and then we can start doing some calculations. Okay, so in the very beginning, it said that he traveled at, let me just get some super thin. He traveled at 100 meters per minute, okay, for 15 minutes, and then he ran back to school, back home in 5 minutes. Okay, so just kind of remember that. So this is in the beginning, this is midway. So let's go ahead and start that. So 100 meters per minute, what does that mean? So that's the rate he's going, that's the velocity he's going, and he's headed towards school. So that means that every minute that passes, he travels 100 meters. So here's 1 minute, he traveled 100 meters. 2 minutes, traveled another 100 meters. 3 minutes, another 100 meters. 4 minutes, another 100 meters. And he does that all the way to 15 minutes. I think that's the dot right there. Okay, so he does that all the way to 15 minutes. So it's not going to be a great straight line, but it's going to be a good attempt. Okay, so that's the first trip that he has, right? So that's the beginning of his trip. So here he finally reached school. Okay, and here he's moving at 100 meters per minute. Alright, now, he realizes once he reaches his school that he forgot his homework, so he has to run back home. Now he does this within 5 minutes. So in a 5 minute span, so he's at 15, in 5 minutes he reaches his house. So that means that he travels from here, right? This would be the distance that he's at his house. So 1,500 meters away, and he travels back home within 5 minutes. So here's 5, this is 15. Yep, 15. That's 5 minutes. That's 20. He travels from there to there in 5 minutes. Kind of eyeball in here. All right, so that's the next portion of his trip. Now, during there, part C, he forgot that he did his homework, so he spent 3 minutes doing his homework. That means that he was stationary for 3 minutes. So 20, 21, 22, 23. He was stationary for 3 minutes, so he did not move for those 3 minutes. All right. And then after that, he travels at 250 meters per minute to get back to school. Okay. So there, he travels every minute. He goes up at 250. So every minute that passes, he is going 250 meters. So there's 250. 1 minute passed. Another. So 250. Okay, another 250 pass. Another 250 pass. Another 250 pass. And then he reaches school. Okay, so this is... So a total of 6 minutes pass before he reaches school. So 6 minutes, 27, 29... Okay, now, just by drawing this, you can determine how far his school is. So just looking at this graph that we created, we know that here he finishes his path, he heads back home. So this spot there 1,500 meters, that's how far his school is. Okay, and then the total time it took him to reach to his destination would be 29 minutes. Okay, if you guys have any questions, feel free to email me. One thing that I will add is if they ask how to determine the rate of the last portion, remember that you do have to find m or the slope. So let me know if you guys have any more questions. Just go ahead and feel free to email me. Yep, I'll see you guys tomorrow in class.